Hello everyone, and welcome to the video on solving rational equations. In this video we will talk about solving rational equations by finding the lowest common denominator, or the least common denominator, aka the LCD, of all the rational expressions across the board. And then what we're going to end up doing is multiplying both sides by the LCD and then distributing to reduce and get rid of denominators. Remember, we talked about this earlier in our time together on solving linear equations to remove the fraction. So basically that's what we want to do. Whether we have variables up top, variables on the bottom, it doesn't matter where we have our variables at. What we'd like to do, the bottom line, is to remove the fraction. So let's start off and build complexity. Something really simple as something like x divided by 7 plus 2 equals 4. All right, so this is a fractional form. And again, we can rewrite these whole numbers as the number over 1. And again, let's just recall the idea is to take a look down here at the bottom. And if we had to come across a common denominator, what would that common denominator be for all three of these terms? And then multiply both sides. So hopefully what we can easily see is that the common denominator is 7. So here I'm going to multiply the left side by 7. So I get x over 7 plus 2 equals 7 times 4. And now the game is to distribute to get rid of the grouping symbols. So we'll just distribute the 7 over here. So I get 7 x over 7. And then we'll distribute the 7 over here over the addition. So I get 2 times 7 equals 28. So now notice that this 7 will cancel with this 7, so that leaves us with an x. And then 2 times 7 is 14, equals 28. So here we have this nice little linear equation that we can solve. So subtracting 14 from both sides. So let's just note that x equals 14. And then we can go ahead on this one. We'll go ahead and do a really quick verify. So all we have to do is take our answer and note that 14 over 7 plus 2, and that's what we want to check. Does that equal 4? And notice that 14 over 7 is 2 plus 2 equals 4. That's what we want to verify. And here we have 4 equals 4. So that's our final answer. Okay, let's take a look at another example here. We got x over 9 plus 4x over 3 equals 26 over 9. So again, we just take a look at these denominators, and I'm hoping that you can easily see at this case in time that we have a common denominator of 9. So let's go ahead and multiply both sides by 9. So we get x over 9 plus 4x over 9. I'm sorry, 4x over 3 equals 26 over 9 times 9. All right, so on the left-hand side, we'll go ahead and distribute. So we get 9 x over 9 plus, distribute the 9 over the addition. So we get 4x over 3 times 9 equals, and then notice here the 9's cancel out, so we just get our 26. So here 9 cancels with 9, so I'm left with an x. And here 3 goes into 9 3 times, and 3 times 4x is 12x equals 26. So combining like terms on the left-hand side, I get 13x equals 26. And now we can go ahead and divide by, whoops, thinking ahead a little bit, divide both sides by 13. So here we get x equals 2. All right. So if you'd like, you can go ahead and substitute back into the original equation just to quickly verify. So we get 2 over 9 plus 4 times 2 over 3 equals, and that's what we want to verify, 26 over 9. So 2/9 plus 8/3 equals 26 over 9. So notice to add these two fractions on the left, we need our common denominator. And let's just observe that if we multiply the bottom by 3, common denominator is 9. Okay, so we multiply top and bottom by 3, it's 26 over 9. So here we get 2 over 9 plus 24 over 9. And again, we want to verify this. 26 over 9. And notice that 26 over 9 does in fact equal 26 over 9. Okay. All right, let's kind of change it up a little bit here. So for our third example, I got 3 plus 2 over a minus 4 equals a over a minus 4. So again, we can take a look, see here, and we can observe that this 3 is just a 3 over 1. That helps you out. And then again, if we take a look at the denominators, I got a 1, a minus 4, a minus 4. I think we can all agree that a minus 4 is the LCD. So let's multiply the right-hand side, or the left-hand side, by a minus 4. So I get 3 plus 2 over a minus 4 equals a over a minus 4 times a minus 4. And again, we're going to distribute this a minus 4 over the addition. So I get a minus 4 times 3 plus, and then again all the way over, a minus 4 times 2 over a minus 4. Okay, and on the right hand side, hopefully we can see that these cancel out. So I'm just left with an a. So not much to do with, so taking a look at this first term, not much to do. So we'll just go ahead and distribute over the subtraction sign to get rid of the grouping symbol. So we get 3a minus 12. And then notice that this a minus 4 cancels out. Okay, so here we get plus 2 equals a. Okay, and again, collecting like terms, I get 3a minus 10 equals a. Bring my a's to all one side. So I'll subtract my a. So 2a minus 10 equals 0. Again, back to this linear equation. So 2a equals 10. Again, just add 10 to both sides. And then divide by 2. So a equals 5. And this is our solution. And due to time, I'll just pause on verifying, but I guess we can really quick. So let's just note that that's 3 plus. Notice a minus 4 is 1, so 3 plus 2 equals 5. And then 5 over 5 minus 1, which is 1, so 5 equals 5, so this works. Okay. All right, so let's go to our next one here. And from this point forward, I will leave the verifications up to you guys. I have gone ahead and done it on my own. So I know that when we get to our final solution for these last two exercises, I have gone ahead and verified. But I will leave the verification up to you. So please do take a moment and verify. So here our example is 2x over x plus 3 minus 2 equals x plus 2 over x minus 3. All right, so nothing to factor, no factoring going on here. Again, I got this whole number thing going on. So again, we take a look. We got x plus 3, I got a 1, and x minus 3. So hopefully we can see that our LCD, let's just agree, hopefully we all agree, x plus 3, x minus 3. So let's go ahead and multiply both sides by x plus 3, x minus 3. Okay, so then we have 2x over x plus 3 minus 2 equals x plus 2 over x minus 3 times x plus 3 x minus 3. Okay. Alrighty. So let's go ahead and distribute on the left-hand side. So our x plus 3, x minus 3, so we get x plus 3, x minus 3. All right, so we're going to take that times our first term, which is 2x over x plus 3. And now we got to bring this, all of this over here. So 2x plus 3, x minus 3 equals, and let's just note that the x minus 3's over here cancel out. So I get x plus 2, x plus 3. Okay, so this x plus 3 cancels with this x plus 3. So we get x minus 3 times 2x minus 2, and I'm going to go ahead and FOIL this, but do we see we have this special type of binomials, x plus 3, x minus 3, and what I'm hoping is that if you FOIL this out, you get the x squared minus 3x plus 3x, those drop out, so we get x squared minus 9, okay, equals, and over here FOILing, we get x squared plus 3x plus 2x plus 6. Almost got it. So here we'll distribute the 2x, so I get 2x squared minus 6x. Now we'll distribute the 2, so the negative 2, don't forget to tag along the sign. So minus 2x squared plus 18 equals x squared plus 5x plus 6. Okay, so this 2x cancels with this 2x. I got a minus 6 x plus 18 equals x squared plus 5x plus 6. All right, so we can see that we have this quadratic equal to a linear, so the game is to bring everything over to one side. All right, bring everything to one side since our x squared is positive, so I'm going to just add 6x to this side. So I'll go plus 6x here. So I get 18 equals x squared plus, add those two, 11x plus 6. And then I'm going to subtract 18. So we get x squared plus 11x. Looks like here we get minus 12 equals 0. All right. So this is a familiar form that we talked about. All right. So the question is can we factor? So I'm saying that we can factor this to x minus 12. X minus 12 times, x plus 12 times x minus 1. All right, since this is positive here, so we can go ahead and verify. So notice that 12 times a negative 1 gives me a negative 12, and 12 minus 1 gives me my 11, and this is equal to 0. So x plus 12 equals 0, so x equals negative 12. And again, we have that x minus 1 equals 0, so x equals 1. All right? And again, I'll leave it up to you, the student, to go ahead and verify that these two answers, these two results, are the solutions to that equation. And I've already done that, and I'm going to tell you that it is true that those are it. All right, so for our last exercise here, our last example, so 5 over x plus 12, I'm sorry, x plus 2, I said x plus 12, equals 11x plus 1 over x squared plus 7x plus 10 minus 12, see there's the 12 right there, x plus 5. All right, so here we have x plus 2, we got this quadratic thing going on, and this linear binomial. So let's go ahead and factor this this dude right here. We need to factor him first. All right, so we get 5 over x plus 2 equals 11x plus 1. And so now the question is, what are the factors of 10 that add up to 7? And I'm hoping that we can agree that it's going to be 5 and 2. I'll leave the verification up to you. So 12 over x plus 5. All right, so hopefully we can see that our LCD in this case is going to be x plus 2, x plus 5. So let's go ahead and multiply both sides by x plus 2, x plus 5. So this takes care of the left side. So now we get 11x plus 1, x plus 5, x plus 2, minus 12, x plus 5. Okay, so this will be x plus 2, x plus 5. So we can go ahead and observe that the x plus 2's cancel. So this leaves us on the left side x plus 5 times 5 equals. So we can go ahead and distribute this all the way over. So I'm going to get 11x plus 1 divided by x plus 5, x plus 2 times x plus 5, x plus 2. Close that bracket as well. And now we'll go ahead and distribute this one across, minus 12 over x plus 5, x plus 2, x plus 5. All right? So the nice thing is these will all start to cancel out here in a minute. So here we get, hopefully we can see as we distribute the 5 across the addition. So we get 5x plus 25 equals, and notice that these will cancel with this. So this all drops down to 11x plus 1. Very nice there. And the x plus 5 cancels with here. So we get a minus 12 and an x plus 2. See, I told you all this stuff's going to drop out and go away. So that's kind of nice. So here we get 5x plus 25 equals 11x plus 1. So we'll go ahead and distribute the negative 12 across. So minus 12x minus 24. So let's go ahead and clean some stuff up here on the right-hand side. So 5x plus 25 equals, so notice that 11x and a minus 12x. So we get a minus x and plus 1, so minus 23. So I'll bring all the x's to one side. So I'm going to add an x here. So we'll go plus x here. So I get 6x plus 25 equals minus 23. So now I'm going to subtract 25 from both sides. So now I get 6x equals negative 48. And then we divide both sides by 6. So x equals negative 8. And again, you can take the negative 8, bring it all the way back up to the original equation. And in fact, if you're going to do this, I would recommend go ahead and use this factored form here. That way you don't have to deal with the squaring and all of that to validate the results. So anyways, that's it for section 7.5 on adding and subtracting, or basically solving some simple rational expressions. You will come up with this again in your college algebra course. All right, so if you have any questions on this, please make note and let me know on your muddy points in the upcoming warm-up. And outside of that, I'll see you in class. Thanks a lot.